Hello everyone, today I'm going to give you a quick review about the cross product. So if you are given two vectors A and B, then what is the definition of the cross product? So there is a formula for that and I could never remember that, to be honest. The way that I used to remember it is I'm going to make a copy of the coordinates and then I'm gonna rewrite the coordinates the second time. Next, I'm going to make something that I call the 3 consecutive clockwise gamma. And remember to start from the second column. So start from the second column, the first gamma is this one. And this is clockwise. What does that mean by these clockwise gammas? So the first clockwise gammas means you are going to multiply A2 and B3. Then you are going to subtract. So A2 and B3 first, then you subtract B2 times A3. B2 times A3. Then A3 B1, A3 B1. Subtracted by B3 A1. Then the third clockwise gamma means you multiply A1 and B2 and subtracted by B1 A2. Utilizing the cross product to find the area of a parallelogram. So for example, if you are given two vectors, then you can always move the two vectors here to form a parallelogram whose sides include the two vectors. In other words, we say that the parallelogram is determined by the two vectors. The way we're going to do that is we are going to move either A or B so that the initial point of A and the initial point of B coincide. So this is also equal to vector A. And they start from the same initial point. Now the parallelogram determined by A and B is this one. And surprisingly, the area of this parallelogram is equal to the length of the cross product of A and B. This is the first thing that I would like you to remember. Now, a direct consequence of this formula is that if you have two vectors A and B being parallel to each other, that means when you move them to form the parallelogram, what you actually have is a completely flat parallelogram, and so the area of that parallelogram is going to be 0 and vice versa, right? So direct consequence says that vector A and vector B are parallel if and only if the area is 0. In other words, the cross product is 0. And because cross product is a vector, so to make difference between vector 0 and the number 0, I'm going to write this. So that means when you cross product two vector A and B, you should have a triple zeros in here, right? So this is a way to test if two vectors are parallel to each other or not. And also, it is also used to test if 3 points are on the same line or not. For example, if you have 3 points A, B, and C, right? If you want to know A and B and C are on the same line or not, you just form the vector AC and vector AB, and then you find the cross product of AC and AB. If the cross product is 0, that means the two vectors AB and AC are parallel, but because they start from the same initial point, being parallel in this case means that they are on the same line. if you are given 3 vectors, then you can move the 3 so that they will start from a same initial point. So in this case, I'm going to move A and C to B. So, now the nice thing is that if you use the 3 vectors here to create a parallelepiped, then surprisingly, the volume of this parallelepiped is the absolute value of the triple product, meaning the dot product between vector A and the vector created by using cross product on B and C. A direct consequence of this formula is that A, B, and C are, say, coplanar if and only if the volume is 0, or in other words, the triple product dot between A and B cross C is going to be 0. So you can visualize this. If A and B and C were on the same plane, then the object, the parallelepiped that was created, will be a flat one, and being flat means 0 volume. So next example. Given 4 points, the question will ask you to find h being the distance from P to the plane determined by the 3 points Q, R, and S. Alright, first of all, if you look at the 3 points Q, R, and S, you know immediately that the 3 points cannot be on the same line, because so this is in the x-axis, this is on the y-axis, this is on the z-axis. And so of course they cannot be on the same line. So if you have 3 points that are not on the same line, they always create a plane through them. So you are going to have Q, you are going to have R and S that are not on the same line. And so there must be a plane passing through the 3 points. Right. So that's one of the basic geometry property. Now you have another point P, and you are asked to find the distance from P to the plane that contains Q, R, and S. And this is denoted as H. Now the trick to do this is that you first connect Q and S, Q and R, Q and P to create 3 vectors. Now they will serve as vector A, vector B, and vector C in the theory. So you can imagine that they will form a parallelepiped. Alright, so the distance from P to the plane is in fact the height of the parallelepiped. So that H is going to be the volume divided by the area of the base. In order to find the volume, we are going to use the triple product. In order to find the base, we are going to use the cross product, right? Anyway, you have to first compute vector QR, QS, and QP. So I will first find the area of the base by computing QR, QS. And so this implies that the cross product of QR and QS is going to be, so you make the copy of the coordinates and then do that one more time, and then next we are going to make the triple clockwise gamma. starting from the second column. So the first gamma means that 2 times 3 minus 0 times 0, which is 6. The second clockwise gamma means that 0 times negative 1 minus 3 times negative 1, which is 3. And the last clockwise gamma means that you multiply negative 1 and 0 and then subtracted by negative 1 times 2, that is going to be 2. Alright, so once you know the cross product, you find the length of the cross product, and that is going to give you the area of the base. The length is going to be square root of square of 6, square of 3, square of 2. And this is going to be square root of 49, which is 7. Now, after you know the area of the base, the last thing you want to do is the volume of the parallelepiped. In order to do so, we need to find the dot product between QP and the cross product here. Right, so first we are going to look for QP. Alright, then next we want to find the dot product between this vector and the vector created from the cross product of QR and QS. So that means you will have to multiply 1 with 6 plus 1 times 3 plus 4 times 2, and that would equal to 17. Now the volume is going to be the absolute value of this triple product. We need to use the absolute value because the fact is that sometimes you may end up having a negative number instead of a positive number, like in this case. So say if you were getting negative 17, then the absolute value will turn it into a positive value, which can be used to describe the volume. So that's absolute value of 17, which is 17 in this case as well. And so once you have the volume, you can divide the volume by the area of the base. So that means dividing 17 by 7, and this is the height or the distance from the point P to the plane passing through QRS. Thank you for watching.